So we are going to just read through the table, which is not always much fun, but it's very instructive. So the references, extremes, metric, time period and data, key findings, and when possible causes identified the study are listed here. So I won't read the extreme metric, but I will just point out that each study has considered a different metric, not always the same, and the key findings are interesting because we have to always make sure that none of them are kind of inconsistent with each other just because they use different data or a different period or a different metric. But it gives you a range of key findings and the range of causes that are identified, and basically underscores the point that extremes are incredibly difficult to diagnose from the data, but Indian monsoon rainfall is one of the best data sets for doing this, and yet we don't always find a typology that can hold true for all time scales and spatial scales and so on, right? So here, for example, 95th and 99th percentile and daily maximum are studied with the IMD data at a quarter degree resolution for 1901 to 2015. The key findings are that increase in magnitude of the 95th and 99th percentile events and daily maxima across all river basins except for the Ganges and Brahmaputra river basins since 1970s, and especially heterogeneous changes in intensity. So the changes in intensity were not at all uniform across these river basins. The focus is on river basins. The causes were identified as the effect of urbanization based on reversal of trends in daily maxima post 1970s towards mainly positive trends. So it is explicitly blaming urbanization as an attribution for the trends observed in these extremes. This is looking at another metric, same data, identifying increases except over parts of northern central and northeastern India. So northern central is towards the Himalayan foothills, and northeastern goes around Bangladesh. It's always funny to see Bangladesh sits in the middle, India collects data over its region, so northeast is kind of circumnavigating Bangladesh in that sense. And enhancement of heavy precipitation events in central and southern India associated with enhanced dew point temperature and attributable to anthropogenic forcing. So explicit attribution here. Roxy et al. We mentioned large-scale events exceeding 150 millimeters per day over at least 10 grid cells. So that's a quarter degree grid point, so it talked about 10,000 square kilometer kind of floods, and argued that there is a threefold increase in widespread heavy rain events so far over central India. We already said that they have gone from about 2 per year to 6 per year now over the last 60 years or so, 1950 to 2015. Increased variability in zonal moisture transport from the Arabian Sea. So the Arabian Sea warming is argued to be bringing most of the moisture to feed these extremes, widespread extremes on land. And there is also a paper by Vittal et al. That looks at warming over land and whether the extremes are locally related to the local warming, and there are only about 25% of the grid points where this correlation is high, which makes sense because the land warming and seasonal circulation produces instabilities, but when you want to produce extremes, moisture has to come from somewhere, which is typically from the ocean, or recycled, which is a large or Gangetic plain, as I mentioned. This is looking at IMD data again, identifying an increase in extremes during low frequency break spells and lesser rain during active spells over central India. So low frequency break spells are the 20 to 60 days. So usually the active and break periods can be split into high frequency, so 10 to 20 days, and low frequency 20 to 60 or 20 to 100 days. Enhanced atmospheric stability and reduction in vertical wind shear. So We have said before that greenhouse gas warming can produce atmospheric stability, and in the case of the monsoon, that can also reduce vertical wind shear, which is blamed for this extremes and the way they are distributed in the active and break spells. So again, you look up what the data and the metric used. I will just read processes just to focus on those. Near doubling of large rainstorms over central India, which is similar to the Roxy Matthew coal, but here the scale is greater than 50,000 square kilometers and the rainfall lasting for greater than 2 days. So these are even more widespread than the one here, and the duration is even longer. They don't necessarily identify any causes, they just point out that these have nearly doubled over this period of 1951 to 2015. This paper reported that increase in area of extremes or intensity over Ganga, Narmada and Tapi, which is on the western side, and Godavari river basins, which lie in northern and central western and northern peninsular India. Okay, just reported that there is an increase in the area of extremes and intensity of rainfall. So again, we said duration, intensity and frequency, but we are also now adding spatial scales to these diagnoses. We looked at this study already. Increase in break days, and increases in short duration active spells over central India in the second half of the 20th century. So pay attention to break periods and break days. Okay, duration of a break period can be 2 to 3 weeks, but you can have multiple break events with shorter break days. Increase in monsoon low pressure days despite fewer monsoon depressions. So this is still arguing that monsoon depressions have decreased, but they are probably lasting longer, so the monsoon low pressure days have increased. So there is still a confusion about what is the trend in terms of the low pressure systems. Here this paper reports reduction in wet spell duration and increase in dry spell duration in wet regions. So this is taking active break periods but looking at climatologically dry regions and climatologically wet regions. So you can now imagine the complications we are adding, which is necessary, by the way, because rainfall distribution is climatologically very inhomogeneous over the whole country, even though we said there are homogeneous regions within the country. So you can look at wet and dry regions. So reduction in wet spell duration and increase in dry spell duration in wet regions, both are becoming longer. Increase in frequency of wet spells in dry regions, which corresponds to the increase in extremes. Variable changes in other characteristics, particularly over dry regions. So intensity, duration, frequency, and divided into wet and dry regions climatologically. Reduction in duration, duration of dry spells over northwestern India, which includes the dry desert regions, and increase in the number of dry days over parts of central and peninsular India. So again, remember that there is a meridional pattern, peninsular India core monsoon zone, and there is a zonal pattern, core monsoon zone and northeast India. So there are differences in the dry spells and number of dry days. Increases in daily variance, increase in the frequency of dry spells and intensity of wet spells. Okay, frequency of dry spells but intensity of wet spells. Decrease in intensity of dry spells over central India. So this is again saying that the daily variance has gone up and frequency of dry spells have gone up, but they have become less intense because of moisture convergence, warming, increased moisture loading, whereas the intensity of wet spells have increased. This is caused apparently by enhanced moisture convergence and convectively available potential energy during wet spells, increase in convectively available potential energy during dry spells, which is reducing their dryness intensity, and reduced vertical wind shear. Okay, so you are beginning to see some points emerging: dew points, moisture convergence, vertical shear, cape, and so on, which makes sense dynamically and convectively, right? Enhanced variance across western and northeastern India, so western India and northeastern India, increased amplitude of interseasonal oscillations, and enhanced moisture convergence driven by Indian Ocean warming. So that's identifying slightly different points and relating to Indian Ocean warming as opposed to just local processes. Reversal of trends post 1950 across some regions. Decrease in frequency over central and northern India and increase elsewhere. Increase in intensity over 66% of the area over the country, and the reason being change points in urban areas in the mid-1970s suggest impact of urbanization, which was also reported in another study we saw before. This study by Charu Singh looked at active and break spells and talked about increase in short duration break spells and moderate duration active spells over central India. Is that completely consistent with the Pai et al. And Dipti Singh et al. In terms of the duration of the active spells being shorter and more intense? Here it's calling moderate duration active spells and short duration break spells. So you have to be careful that they are not completely opposite to each other. Slower propagation of the 20 to 60 day intraseasonal oscillation, which was also identified by Sabir Ali and explained with those series of processes for change in amplitude and propagation speed of the mesos, right? Moving forward, this looked at the return periods for annual maxima using some statistical extreme value method. Found that lack of uniform increasing or decreasing trends in terms of temporal extreme metric. So instead it talks about enhanced variance of spatial of extremes, enhanced spatial variance of extremes, which we will see again in a figure which we already saw once before. This study here, increase in short and heavy intensity spells across peninsular, western central, northwestern, central, northeast India, and most agrometeorological regions except in the rain shadow regions of central India and northern hilly regions. So it's identifying some orographic effect, which I should have mentioned before. There are some evidences that in the mid-latitudes, instead of the windward side seeing more extremes, the leeward sides are seeing more extremes with warming. So this also has to be explored in the Indian context. Decrease in long moderate intensity spells and long and short low rain spells across all homogeneous regions and some agrometeorological regions. So you can just see how many properties can be looked at and how findings are reporting them as well. Increase in intensity but shorter duration wet spells, which is consistent with what we already said, and weakening intensity but longer duration of dry spells across most Indian subregions. So this is completely consistent with the Dipti Singh et al. Paper from 2014. Continuing some more. Robust rising trends over eastern central India. So eastern central India that we talked about, that goes from Himalayan foothills over to West Bengal and Odisha. Increase in synoptic activity index associated with more weak LPS systems. So again, this raises questions about whether there is a trend in low pressure systems, monsoon depressions, or there is a compensation in terms of an increase in the synoptic time scale of 3 to 10 days and decrease in the lower frequency in terms of 10 to 60 or 10 to 100 days, and what it means in terms of the extremes over eastern and central India when the extreme rainfall days are defined as greater than 95th or 99th percentile. Rajivan et al. Looked at active and break spells, but for a period of 1951 to 2007, and reported no significant trends in active or break spells over central India. So again, not somewhat inconsistent maybe with the Singh et al. Paper, which also looked at the core monsoon zone. This study here increase in intensity across much of central and peninsular India, but heterogeneity in frequency trends. Approximately 3 times more grids show decreasing 90th percentile frequency trends than increasing, but opposite for the 99th percentile. So use the definition of extremes can make a difference. As we said before, it's about which bins you are looking at in terms of increasing frequency versus decreasing frequency. This study here looked at 1 degree by 1 degree grid. So you can see that IMD has multiple products and people have used different resolution products. Increases in heavy rain events in northeast and decreases in moderate rain events across all regions, which is consistent with the Goswami et al. Paper. Increase in short and prolonged dry spells across all regions but the northeast. You have to figure out if that's consistent with the study of Singh et al. In terms of reduced intensity of the break events. The cause here is reported as increase in low pressure systems, but decrease in depressions and increase in severe cyclonic storms. So now it's binned the cyclonic systems into low pressure systems, depressions, and severe cyclonic storms, and it's splitting them, but it's looking at 40th to 99th and greater than 99th percentile events, and short and long spell dry events with less than 2.5 millimeter per day. So I hope someday somebody will synthesize all these. I think we are coming to close to the end here. Increase in frequency of very heavy rain events since 1950s and decrease in frequency of moderate rain events over central India. Cause being Indian Ocean warming resulting in enhanced evaporative flux and moisture availability. This is a common theme. In the next paper, this we already discussed in the first few podcasts, increasing trend and intensity of extreme rain events and opposite trend in moderate events over central India. Warming of tropical Indian Ocean again held responsible. This one looked at increase in northwestern India, western central and peninsular India, and decrease over eastern central India. Looking at station data, this also looked at more station data, longer different period, and reported an increase in western coastal and western central India, but decrease in southern peninsular India and lower Ganges basin. Okay, so I will leave that here just to give you a sense of how many studies have focused on extremes but have also found results that are differently focused, causes differently explained, and unfortunately in this quick run through we cannot always say if they are all consistent with each other, but the processes are all the ones that we have identified. Again, they can be mapped onto vertical motion, precipitation efficiency, and the saturation vapor pressure changes with temperature along moist adiabats, which hopefully somebody will do in terms of the scaling. There have been some studies during short duration extremes and their scaling over India by Vimal Mishra and his group, which I haven't included here, but that is consistent with what we said before in terms of the short-term duration extremes versus daily and longer time scale extreme events. Okay.